Hello, everyone. You are continuing and studying, and this session for the next an hour and a half will be devoted to the how we perceive and sometimes or very often misperceive some information. We will focus on mostly on maps and some visual information when we create graphics, infographics, and maps. What may go wrong. My name is Natalia Zaika, and my colleague Volodymyr Mahita, we will share this presentation. We are from American University Kyiv, and more specifically, we do behavioral economics. This is our main field, and this is because we are here, because we are not in agro, but we study how people perceive different information, and we try to understand why when we say something or show something, people perceive it differently than we expect them to do so. I will start with talking about what is behavioral approach, because this lecture is about behavioral approach to data perception and data creating. Everyone who is in behavioral studies, when talking about behavioral economics, will definitely think about these two guys. Does any one of you know these people? Daniel Kahneman and Amos Tversky, who have heard about them? I know Natalia heard, yes, a couple of you, very good. So of course, they are often called the fathers of behavioral economics, two brilliant scientists and two very good friends who were basically psychologists, but it happened that at the end of the day, Daniel Kahneman got his Nobel Prize in economics, because he combined his psychological knowledge with economics. When he met a lot of prominent economists, he thought, okay, guys, what are you doing? How you think about people? Have you ever heard real people, or you are just sitting in your libraries and labs? Because people do not behave in a way you economists expect them to behave. So the combination of this psychology and economics gave us a new field, which is now called behavioral economics, and it is one of very maybe few or more maybe the only one field that has, we can say it has the exact birth date, because their publication in the journal Econometrica in 1979, which is called Prospect Theory, is supposed to be the day when behavioral economics was born. This is the non-fiction book wrote by Kahneman, Thinking Fast and Slow. Highly recommended for those who are interested in this field. It is also translated in Ukrainian, Мыслення швидке порівняння. You can find the basic theories of that in this book. So, what is the core of behavioral approach and behavioral economics? Basically, these two people, they suggested that we all humans have two systems. When we are thinking, there are two systems of thinking. They didn't think a lot of that, and they just called them system one and system two. No fancy names. But what is the idea? System one is fast, intuitive, automatic, unconscious. So basically, this is the first answer or the first thoughts that come to our mind when we think something. When I ask you what is 2 plus 3, you all know this is 5. And this is the system one that gives you the answer. And system two is different. It is very slow, rational, and logical. So when you have some complex problems or questions, and you don't have this automatic answer, then the system two becomes thinking and becomes looking for an answer, and maybe give you an answer if it can. But it also comes with a cost. It requires a lot of efforts, a lot of mental efforts, and a lot of resources from us. So we are so tired when we thinking very, very hard, when we're working on hard problems. We become very tired. We want this chocolate bar very fast because we need this energy. This becomes system two, requires a lot of resources from us. But basically, why I'm talking about these two systems, because I want us to think which of these two systems are more useful for us, or which we should use more often, which is gives us more useful information or more smarter decisions? System 1, system 2, what do you think?
I think both.
Both, okay. Any other thoughts?
To survive system 1.
To survive.
Sustain profit system 2.
So the second one?
To obtain profit.
To obtain profit, okay, yeah. Sure, of course we need both. And we use both. And what is very important, this is not like the physical parts of our brain. No, this is not. This is just a hypothetical construction of how we think, how we make decisions. And system 1 is very important for a lot of decisions and for a lot of things we do during the day. Because when we wake up in the morning, we do something automatically. We don't think too much how to get to our work or study or whatever. So I know 90% of things we do because we already know how to do that. And system 2 only should be turned on when we face some new problem we don't know about. I'm not from Lviv, so to get to Sheptytsky Center, I need to think a little bit or to open the Google Maps just to get here, because this is not my usual way. But when I'm in Kyiv, I go from my home to my work, like I don't need Google Maps for that, okay? So this is the difference. Now we'll see how it works and why it is important. So what is this? What do you see on the slide? What is this? Yeah, no tricky questions here, just a simple one.
Is there B or 13?
B or 13. So I believe that when you saw this, B is okay. Yeah, is two letters, right? So when you see someone may think this is letter B, someone may think this is 13. If I show you this slide, I believe no one would say this is 13. Everyone says this A, B, C, right? So this is just very simple. If I show you this slide first, I don't believe someone would think this could be a B. This is very simple. This is 12, 13, and 14. So depending on the context, we may very easily perceive this piece of information, or we may think differently about it, and we may, like different people, may see something different in this very small piece of information. Here are two circles, and maybe if I'm asking this question, it's easy to answer it. But the question is, are they two perfect circles, like the regular circles that they should look like? And again, no one will see them. They seem like drawn like handwriting, right? But yes, we can put on the right circles, and we can clearly see that they are just perfect circles as they should be. Again, our brain is not perfect, and sometimes when looking just a very, very simple information, we cannot perceive it as it is really is. Another example. So here we are looking at these A and B cells, and can anyone clearly see that they are of the same color? No, the answer is no. Yes, I know the answer. No one. We think that the A is much darker than B. I checked it with Photoshop. You may do the same. They are exactly the same color. But because of the context around and because how it is presented, we will never see. And the interesting thing is that even when I told you, and you may check it yourself, well, our eyes are not able to see that they are of the same color. If you see, I just draw two lines of the same color, and when there is like the lines around, it is much easier to see that they are the same. Okay, a small perception experiment. You will see something on the slide for a very short time, and 1 second, 2 seconds, whatever. Just look attentively, and then I will ask you a question. Which card do you see in the center?
First, with red color. I don't remember the exact one, but
okay, a red 4. Who else?
I saw 5.
You saw 5.
Black.
5 black, okay, at least
Black 4.
black 4
Space, yeah.
4 space. Okay. Okay. Any other ideas? 4, 5, whatever. Okay. Let's see.
Yeah.
4 huts. So one you had a very but huts, black huts, right? So this it doesn't exist, right? So this is a combination of this shape and this color, which doesn't exist in the regular cards. So you had a very limited time to see this slide and to catch what is on the slide. And what happened? You saw some piece of information, not all. Someone saw, for example, only 4 or 5, whatever. I don't know why. But someone, the brain of some of you caught the shape. Yes, and if this is the shape of heart, it should be red because we know the pattern, we know the rules. If this is the cards, if this is the heart, then it should be red. Someone catch the color. And if this is the color, it is very similar to this one, right? So we believe this is the card. What does it mean? So when we perceive some information, when we read something, when we see something, we sometimes miss or we don't have enough time, and we always don't have enough time because there's so much information around. The brain suggests us that it suggested something that is already familiar with. So if we know the color, should be this shape. So we don't perceive everything from the scratch. Our brain gives us already some hints or some information it already knows. Okay, probably the last final slide. How many black dots do you see at the same time on this picture? Do you see at least any black dots?
Yeah.
Okay.
4.
At the same time, you just look at in one point and you see how many?
I see 1 at the same time, but I see 4. No, it's not 4. It is 8. Yeah.
8, okay.
I think
But you
it's not 8. 12.
Exactly, yes.
12.
Here are 2 12s, 4 in a row and 3 rows. But we cannot see them at the same time, right? If you focus somewhere, typically it's pretty easy to see 4. Some people can see 6. Very, very rare that people can see 9, but it is impossible to see all 12 at the same time. Again, what is this about? It's about the complexity. So every information we perceive is typically very, very complex. And we not always know what we have to focus on, and we miss some pieces of information. An example, this is the map of Ukraine, of course, and the land plots trade agreements are shown on the map. The map was created by Casey student for her master thesis, and here are the dots, very similar to these dots, right, on the map. So she put the trade agreements on the map with those dots, and what is the story behind? What can we tell about the trade agreements with the land out of this map? What do you see here?
This for a huge density in Kyiv and Poltava regions.
Okay, yes, the density is different in different parts of Ukraine. So what does it tell us? What does
People
it mean?
are scared of Russia.
Sorry?
People are scared of Russia.
People are scared of Russian because?
Because like there's war. And like
No,
not...
out of this map, why did you conclude that?
Because there is less density near Russia.
Okay.
Or near Russian occupied territories.
In Belarus.
Yeah.
It's like a line from the Russian mountains to the east of Ukraine, just a little bit above the center. because we can see its density, under is smaller. And
Okay, so we see some regions where we had more agreements, more land plots were sold, and somewhere less. But does it necessarily mean that the more square kilometers were sold here with higher density and less here? It might be the case that here in the east, in the south, the size of the plots are bigger because they are, I don't know, for some reasons, like this is like just big fields of something, of watermelons, whatever. So the one dot of one trade agreement doesn't necessarily mean this is the same plot, right? So maybe there are a lot of small plots and here are a lot of large plots, and this data means that maybe here the size of the land that was sold is still larger, even if the number of agreements is larger in the other parts. So this is an example of how we can differently perceive or differently interpret the information we see if we don't have any other explanation or other context. Of course, this was a part of the master thesis. There was some words around the map, and you could understand from the text, but my message here is that when you create something, you create a map, infographics, whatever, it is your responsibility to explain what's going on, because maybe it's very clear to you. Okay, you just watch and you just look at it and that's it. But this is not the case. People may not, maybe people don't know the context behind that you know. Okay, I will now conclude this first section, this small introduction. Why I entertained you with all those funny pictures? Because this is about the perception of visual information, and which all of us have. Because sometimes in the audiences, when I present something similar, people in the audience typically think, okay, these are other people who are not smart enough, so they are looking at the graphs or whatever, and they don't understand what's going on. But I'm very smart, I'm well educated, I'm the graduate of FUKU or whatever, so I will never do those mistakes. But when we try some experiments in-house, it's not because we are not smart enough or we have bad education. This is just our brains, and it works in a very similar way of all of us humans. So we all make those mistakes of perception. So small like takeaways from this introductory part. The brain perceives everything in the context. This is the example of ABC and 12, 13, 14. So when you present some new information, it should be related to some previous information. You should provide the context around the information. The brain can easily make mistakes, even with very simple information, with the shape, with the color. And what does it mean? You always need to provide more information than just on the one graph. You have to explain what's going on. And you have to point the attention of your reader or listener, what is the most important here on your slide or your text, whatever. The brain adds some information that is missing. We saw it with the cards example. So again, this is your responsibility to provide complete information, because sometimes people will like add something they knew before, but it might be irrelevant. The reality is very complex, and we always miss something. This is the example with the dots. So if you want to attract the attention to something, you have to clearly do that with your data visualization. So it's your responsibility to make sure people who reads your text or watch your slides, whatever, they don't miss the most important information you want to tell them. So you have to tell them the story behind your slides, graphs, and maps. Given that, I'm doing the link to the next part, and the most common biases, because in behavioral economics we call this misperceptions and perceptions of information and decision-making biases. And regarding the cards and graphical information, there are three most common biases. The first one is color bias. We saw that we do not perceive the color as it is. The shape bias, we also saw the examples, and scale bias. And basically, during the rest of the lecture, we will talk about all these biases. And the last one from my part, this is which bias it is?
Visual or
Color, shape, or scale?
shape.
Shape, yes. Because this is the perfectly parallel lines here. But again, we don't see it if we do not come with a ruler and just check it. Okay, this is all from my part. I pass the floor to my colleague and we will continue.
Thank you very much. And what I'm going to do today, I will talk a little bit about maps. And the question is, what is a map? What is a map? Who knows what the map is?
Graphical representation of the landscape.
Kind of. One important question, how neutral the map is, how neutral the map should be. Because once we draw a map, we believe that if we put some information on the map will tell everything for itself. Alas, it's not exactly the same because how we draw the map very much defines what we are going to tell with the map and how people perceive information on the map. Color, size, scale, position of the regions, number of the regions, the absolute and relative size of regions, they all matter. So whenever you put any information on the map, you should have, you need to keep this in mind, and I'm going to talk a little bit about all of this. So the question is, what kind of story we are telling with a map? First, a bit about spatial data. The old way of presenting spatial data is table. So we just draw a table. In this table, we, for example, get the list of the countries, and for each of the country, we say, for example, how many genus each country has. This is what is called georeference data because we kind of imagine where each country is located. We can look at the map, we can look at the globus, and then we more or less understand what's going on. Another way is geocoding. Geocoding means each data point that you work with has some kind of coordinates, and then you put those coordinates on the map. Did you try mapping, some of you already, something? Did you try using ggplot, whatever? I use Stata, but well, different people use different stuff. So geocoding is how we draw the map. Once we are talking about the objects on the map, first, this would be points. This is just some map. On this map, you put the coordinates of each phenomenon of each event that you have. Second would be lines, which could be arcs. This is roads, this is pipelines, this is some routes, something, whatever. And this is also polygons. Polygons is, for example, this would be areas which represent cities or some oblast or whatever. And if you look at this, we can start with very old example, 1854, outbreak of cholera in London. Cholera was spreading around some region, and then there was one guy whose name was John Snow, and this is different John Snow than the one that you probably know. He decided to put some data on the map. So he has got the map of London, he put the cases of cholera on the map, and he pretty much understood that probably the distribution of cholera is very much related to the distribution of the water system. So the idea about how cholera was spread out was not there yet, so people didn't know much about cholera, and a lot of people thought that cholera was distributed in the air. And John Snow, using his map, actually suggested that probably the cholera is distributed through the water supply. And then he recognized that one of the water pumps, one of the water columns, was in the contaminated area, and this was the source of the contamination for the entire area. And right now, if you happen to be in London, you can see one of those columns discovered by John Snow as the monument to that epoch, because this was very important discovery and one of the first uses of the map for this so-called exploratory spatial data analysis. But once we are talking about maps, so first is the one that you have seen, just static points. If it is provided as a test without any explanation, it doesn't tell much of a story. And you have seen from the previous discussion that you have to come up with your own stories to understand what is going on. For example, the density of the dots in the lower part. Is it because there were few deals, or is it because the land parcels were of the larger size? Unless we know the text, unless we read the physics, we probably will not know about this. So the dots is the easiest way to put on the map. But again, you have to be very meticulous in how exactly you do this and what kind of story you would like to show with this. Or for example, some maps which zoom in. So for example, this is developer's plans for, I guess this is for Kyiv, I don't remember, maybe for Lviv. And then if you zoom in, you can see more and more data points. So this is, for example, where development plans were about 10 years ago. Or, for example, you can put dots of different types. So, for example, if we are talking about just different urban infrastructure, you have different colors, so different size for different objects on the map. Also, you can use the surfaces, so such as the heat map. Heat map is basically extrapolations of the dot maps. So there are some dots. Based on those dots, you extrapolate the area around those dots, and then those areas they merge together. Then you see this extrapolation. If this is the map of the temperature, for example, this is probably okay. If it's the map of, for example, some more nuanced things, for example, crime, or maybe some land deals or something like that, this could be a little bit overshoot. Or another type of the map is something which I call ISO something. ISO bars, ISO terms, this could be ISO cost, this could be lines which determine, for example, for agriculture, this could be lines which determine some price of the land agreements, or maybe the quality of the land, or maybe some natural zones or whatever. ISO something, they basically show the border of the regions with the same characteristics. Also, maps usually require something in addition. So, for example, this is the map of the weather station connected to the heat map. So those weather stations, they are located all around the globe. There are several thousands, there are dozens of thousands of them. And if we know exact location of each weather station, which is kind of open information, we can use this information to predict the temperature in the particular region based on some very complicated meteorological models. And this map shows not only the heat map of the temperatures, but also it shows where those stations are located. And actually, if you're interested in Ukrainian metro stations, you can find information about them. There are at least 2 or 3 websites where exact locations of those metro stations are. Or, for example, layers. This map that we all know, there are several layers on this map. Actually, how many layers, if you know what the layer is? How many layers do we see here?
Layer what?
Layer is basically different type of surfaces. So, for example, layer 1 would be borders of the countries. Layer number 2 would be borders of the regions within the country. So, layer number 1 would be the country borders. Layer number 2, let me get this laser pointer here. Layer number 2 would be borders of the oblast. Layer number 3. This could be all the areas which have been occupied in one moment. So, for example, this one, all those areas have been occupied. Again, this is kind of interpolation, but this is something. Layer number 4, areas which have been liberated. So the green areas, these are the liberated areas. The red areas are occupied areas, and there is another layer. This is the areas which have been occupied before 2022. So this is Donbass area and Crimea. So we can see that we can impose all those layers so that the map becomes more and more complicated, but it should not be too overcomplicated. If you put another layer over here, for example, some map of the oblast, it might become non-readable. Yes?
Sorry, do I understand correct? Prидnestrovia is highlighted as occupied?
Yes.
Yeah.
Yes.
There's Russian troops.
Yeah, the Russian troops are there.
But before 23.
Yes.
Yeah.
There was 14th Army over there, which was continuing from actually when Pridnestrovia became Pridnestrovia. So since 1991.
I guess.
But it's the color of like currently occupied.
Yes, this is the color of current. This is the color of the occupied territory. This was occupied. This is the territory which is occupied. This one was occupied before. This guys on the deep map that decided to use this color before, but they just simply mark this one as the occupied territory. Not that I intended to be the night of geographical discovery. There's also another way which is called horopleth maps. Not the chloropleth, horopleth. Horopleth actually means a combination of color and area. Hor stands for color in some Greek. So this could be oblast, this could be rayons, this could be territorial units, this could be census tracts, this could be some election polls, this could be states. It is not necessarily continuous, which means we see very clear different data points. So this is data point, this is data point. Polygons are usually quite sizable, and there is a manageable size of those polygons. I used to build Ukrainian maps with those polygons. They used to be very many polygons. They were not very informative. I will show you that. Also, the polygons usually fully exhaust the entire place. So you see the entire map of the United States, which is covered by all those polygons, which is basically the states. And most of the time, those polygons are externally given to you. So for example, if you want to draw a map like that, you need to find a file which physically has borders of oblast, borders of rayons, borders of OTG, or borders of everything that you need. Those files, they are round, they're called shape files. You can use those shape files, and then you connect your data with those shape files, and you create your own map, and this is easier than to find those shape files first. Also, sometimes the units are not necessarily going to be standardized. So this was a map from my dissertation where I wanted to see agglomerations around Ukrainian cities. So this was algorithm which I developed to draw this. So I basically got the major city, and I got all the adjacent rayons around the city. Then I got the next major city. I got rayons around that one, and so forth. I repeated like 55 times. So this was a quite complicated algorithm, after which I drew this map. The color changes from blue to red, and the blue it is, the more it goes to the blue, the largest agglomeration it is going to show. So for example, Kiev is the first largest agglomeration, then I think it was Kharkiv, then it was Donetsk, then it was Dnipro, then it was Odessa, then it was Lviv, and so forth. So it shows just areas of agglomeration, so those kind of areas around big cities. Not exactly, not the most adjacent, like the second adjacent also was there as well. So I was just trying to show how those agglomeration map looks in Kiev. But you see that this kind of map is not something that you will see anywhere else. So this is kind of my own creation. Another thing is another part of the maps is something which is called arcs. Arcs would be, for example, roads, would be rivers, would be pipelines, and they usually should be combined with something else. So this is like additional layer on the map. And they're used for the illustration. They're quite difficult to work with, but they're used for illustration where some geographical object is located. And again, if you look at this map over here, it shows all the major pipelines of the gas transportation. But obviously, this is not everything. This is just the major pipelines. If you look at the map of the roads, again, you see only the major roads, but not all of them, because if you put all the roads, it becomes unusable. So you always have to choose what the level of detailization of the map is. But why we need all of this? For example, we have to find the distance between two oblasts. How to find the distance between Lviv Oblast and Kiev Oblast? You can use centroids. Very good answer. The next question, how to find the distance between Odessa Oblast and Kiev Oblast?
Nearest point.
You can use centroids. Do you know the centroids for Odessa Oblast where it is located?
In Moldova.
In the sea. So if you want to find the distance between two oblasts, this is the problem, how you find a certain point on the polygon. This is like the geographical problem here. And the question is, okay, this could be centroids. This could be the administrative centers. You know the administrative centers. If your centroid is kind of administrative centroid, right? sometimes it's just very interesting because for Moldova, for Odessa, centroid is somewhere over here. So if you use centroids, you will not be able to find it. This is kind of aberration. That means you will have to tweak your scales a little bit. And usually the larger the object, the lower the precision. But what is the distance between Lviv and Warsaw? Give me some approximation.
Maybe 800 kilometers.
No, 350.
Almost 500 actually, using the Google Maps. Almost 500. What about distance between Lviv and New York?
7,000.
7,000 exactly. The previous one was the road distance. The second one was the distance between airports, between Lviv Airport and New York Airport, which is, well, in New York, there are 3 airports in New York, but okay, 7,000 plus or minus 100, no, nobody cares, right? What about this one, Lviv and Skneliv? For those who are not from Lviv, between Kiev and Brovary is pretty much the same.
Where is it?
20.
20. What the problem is, if you look at the map of Lviv, Skneliv is almost on the border of Lviv. It's actually kind of inside, like this is like the greater Lviv area, if you want. So if we are talking about the distance, suddenly it becomes very important where we are measuring the distance from. And this is something which is kind of, if you measure this from the same point where you measure the distance between Lviv and Warsaw, this is about 12 kilometers. When we get in the taxi over here, I asked the driver, the taxi driver, I said, may I ask you a very professional question? He said, yes, of course. I said, what's the distance between Lviv and Skneliv? He said, well, Skneliv is almost in the city. I think it's not more than 3 kilometers. Because once we are talking about the questions like that, if the geographical points are very close, people immediately get a different reference point. And the reference point for measuring distance between Lviv and Warsaw would be city centers. But measuring the distance between Lviv and Skneliv doesn't make much sense to measure the distance from the city center because Skneliv is so close that it immediately, the question is where are we going to measure suddenly becomes a very important issue. On the other hand, if we measure the distance between Lviv and New York, we can get the point which is outside of Lviv, which is the Nilgalinsky airport, and one of the points outside of New York, which is Newark or JFK, whatever, which is kind of outside of the city, and this is still kind of okay. So depending upon the distance and depending upon the scale, it's very important how we measure the distance and what are the reference point. Again, in behavioral economics, we always talk about the reference point in the context. Here, we're talking about context as well. So once we're talking about other data transformations, very simple question. For example, you have some milk processor plant, and you have milk farms around in the area. The question is, what is the service area of this milk plant? Usually, well, it was a kind of the common knowledge when I was studying all of this stuff that the processing area for the milk plant is in the radius of approximately 200 kilometers. Because usually it's just much more difficult to get the truck that transports this milk. It's usually more difficult to send this truck over 200 kilometers. But the question is how to build this area on the map, how to map it. Well, first is again polygon to point. We build centroids of each unit. So, for example, we have the data on AutoGAP. We know that in each AutoGAP there is some certain number of milk producers. For each AutoGAP we put the central point, and then we basically draw the map based on the central points, something like this. So if we have those maps, those points are connected to the AutoGAP, and we build a map which looks approximately like this. But there's another way, it's just called Thyssen polygons. Thyssen polygons works in a pretty interesting way. If you have data on the map as dots, you connect those maps, those dots with a straight line, and then you draw a perpendicular. And then you draw a map which is based on those perpendiculars. And then you get a map that looks like this. So the size of each polygon depends upon how many neighbors there are and how far those neighbors are from each other. So this is another way to extrapolate the area without referencing to real points on the map. So this is just a model here. Yes.
This is called Voronoi diagram after Georgi Voronoi.
I think this is kind of two names out there.
Yeah,
this is Voronoi diagram. Thank you. But then, how to build those service areas? And here, where the real life question actually come into the picture. So what we need to incorporate, for example, there should be some natural barriers. Once I saw a map of Cherkasy Oblast, and the distance between 2 points was 5 kilometers. But the problem is those 5 kilometers included Dnipro River. So 5 kilometers, but the road distance was something like 55. Because to get from one point to another, you basically had to find the nearest bridge. And for example, the same refers to the distances between points in Romania and points in Bulgaria. If you didn't know, the Romania and Bulgaria are divided by Dunai, the Danube River, and there are some ferries across this Danube, and there are a couple of bridges. But actually, they're pretty rare, so if you need to get from Romania to Bulgaria, sometimes you need to spend something like 3 hours to get the distance, which is something like only 5 kilometers from the map. So the natural barriers are important. In the cities, one of the important barriers would be railroads and big roads. So once we are talking about big cities like Lviv or Kiev or Kharkiv, every big road is actually a natural barrier. Because of mobility, because of the disabled, because sometimes it's very difficult to get from one point to another without looking for some pedestrian crossing. Or this could be administrative barriers. So for example, there are 2 farms which are located in 2 different oblasts. And then the question is, or not even an oblast, in 2 different OTG. And right now, every OTG has its own kind of autonomy. And then the question is, if we would like to build, to invest some money into those farms, we could immediately, even though those 2 farms are only 10 kilometers away, if they're located in 2 different oblasts, you have to talk to oblast administrations in 2 different oblasts. And sometimes it would be much more expensive to invest into 2 farms which are located only 10 kilometers away than into another farm which is located in the same oblast, something like 20 kilometers away. Simply because you don't have to deal with all the oblast government with different regulators, so different people, sometimes it's just easier. So administrative barrier is the natural barrier that you have to take into account. Or this could be population density, or this could be farm density. So for example, if there are too many farms around, this is also some barrier that you have to take into account. Or this could be internal company structure. I don't know if you heard about the scandal with Hala Baluvana recently, no? Yeah? Do you remember the essence of the scandal? One of the problems, each franchisee in Hala Baluvana has so-called protective area around. And previously it was 2 kilometers, so that means in 2 kilometers radius you cannot build another franchisee of Hala Baluvana. But then they decreased this area to 1 kilometer. So basically, if it wasn't possible to have one more Hala Baluvana within 2 kilometers, now it's possible to have another Hala Baluvana within 1 kilometer. And for dense areas like Lviv, this is not necessarily a problem, but for smaller cities like Stri, for example, this is a huge problem. Because it basically means that if you were more or less monopolist on the big area, you basically lose monopoly, but you also lose a huge part of the market. And this is the franchising condition within the company. So this is something that you have to take into account. Or for example, if you have some kind of company which has East and West divisions, for example, before 2014, a lot of companies, international companies which serve Ukraine, were located in Moscow. You don't deal with those international companies otherwise than through Moscow. After 2014 and especially after 2022, a lot of those things have changed, and some of those big international companies have opened Ukrainian divisions somewhere in Poland, but they did not consider this region as the part of the Poland division. They considered it as a part of the Moscow division. And this is also kind of important to understand where all those things are. This is the natural barrier. And of course, there could be some competitors. So you put if you put your objects on the map, you also have to put competitors to understand what are the physical relations between them. Another thing is something which is called modifiable area unit problem, and you can see this on a very simple example. So let's presume that we have how many? 3, 4, 12, 20 points. And these 20 points can be divided into the equal regions. So in this region, we have three black points, 2 white points, and they are equally divided. Or we can divide this into 4 regions so that this region has 6 points, this region has 6 points. So this is a kind of very dense distribution. And this is very sparse distribution with only 4 white points. Or you can divide the area into 16 objects so that some of those areas have only 1 object, some of those areas have 3, and they're located in the center. And also you can basically naturally divide having this as the single reason, and this is some kind of the periphery. Depending upon how you slice up the space, depending upon how the space is already sliced up by the administrative borders, you can see completely different picture and completely different statistics about the particular geographical or economic phenomenon. So if you have just the point data and you put this point data on the lattice, on the surface of the country, it becomes very important where those borders are. Because if this is just 1 unit, it looks like that. If this is many units, it gives you a completely different perception. So depending upon what you would like to say, this picture you can say, see, all our country is covered by our companies, by the branches of our company. What can you tell over here? See, the branches of our company are located in every administrative region. These are 2 different stories. This one shows the countrywide coverage, and this one is useful for international investors, for example. And this one is the story for the internal consumers. See, we are so conveniently located that you can reach us in every administrative region. For example, if you look, I don't know if you know this producer of mechanical tools, DPRO-M. Now, right now, they advertise that we are located by near every metro station in Kyiv. It's very convenient to buy the electric saw just getting there by metro. So this is the statement which is also located, which also is told based on this story here. I don't know if many of you have heard about gerrymandering. Gerrymandering is the special slicing of the electoral units. So, for example, we have 50 people who equally cover this territory, and this territory is covered by 40% red, 60% blue. So first, this would be perfect representation. We cut the regions. We cut the regions by vertical lines. These are just administrative regions, or not administrative, electoral regions. Then we have 3 blue districts, 2 red districts, which more or less represent what's going on in the entire area. Or we could cut them by horizontal lines. So in every district, we see 40 to 60% representation. However, if we are talking about, for example, local elections, in those local elections, everywhere the blue are going to win, and there is no chance that they're going to lose. So this is all the districts are blue. The red districts there would be red 0 districts as a result of those elections. And gerrymandering comes when we recut the area so that we have 2 blue districts and the rest are red districts, because the territories are covered so that, since we know the sociology from in advance, we have cut the borders of the electoral regions so that the reds have this unfair advantage. Even though the number of people who vote for red is lower, as a result of cutting the electoral area in this way, the red are going to win.
But on the left side, we have a second district where blue will win.
Over here, the blue will win. Over here, the blue will also win. Over here, the blue will. Over here, they're going to be more or less equal presentation. Over here, blue will get the entire parliament. Over here, red will get 60% of the parliament. if you follow the international use a little bit, right now there is a huge arguing in Texas and California about how to reshape the electoral districts. Because it very much affects who is going to win the next elections. Basically, Democrats, Republicans, and it suddenly becomes internationally important. Just points on the map.
I have a question, sorry. This is in the United States, this system is different near the Ukrainian or Europe. And how does it, mathematics model is completely, how it wins, what is difference?
If you're thinking about the local elections, for example, elections to the parliament, which is based on the electoral districts, this is pretty much the same story. So if you're talking about the presidential elections, this is completely different. I'm not talking about this. I'm talking about how the parliament is going to be represented.
Okay.
So if we redraw the electoral map of Ukraine so that people who voted for Zelensky will be somehow spread around the regions in unequal parts, it might be possible that we are going to have the parliament which is much more pro-Zelensky than under the natural map. So this is something about this. So this is about redrawing. Actually, if you know something about how Orban came to power, this is this picture.
Okay.
Gerrymandering. So now something about size, position, and color. Question is how much larger Russia is than Africa.
There are distortions.
Yeah, there are distortions, 2 times distortions, something like this. I like this map, which is called true size. So this map basically shows true size of Russia, but because of those distortions, Russia looks so huge. If you put the map of Russia as it is on the map of Africa, it looks like that. But what is interesting, if you turn this map of Russia 90 degrees like that, it seems that it covers almost the entire territory of Africa again. So this is something which is kind of very difficult with all those Mercator proportions, but this is the news from yesterday in Guardian. African countries said that it is unfair to use Mercator projection because Mercator projection distorts the size of Africa, and they would like to show the size of Africa as it is. Again, this is something which goes on in the real life. This is something that we have to take into account when we work with the world data. For example, when we work with with the map of Ukraine, depending upon which shape file of Ukraine you are going to find, you can find the shape file where Ukraine is very much stretched from east to west, or sometimes it is stretched from north to south, and you have to tweak the coordinates. So you have to, if this is a specialized program, you have to choose the specific proportion to correct for that, because otherwise the map of Ukraine can seem that it's extremely stretched from east to west, and it also provides some distortions which distort perception of the information that you need. Projection matters. So this is the usual map of the world that you have probably seen from your childhood. This is another map of the world that you probably have never seen. On this map, Africa is much larger, but China is in the center. This map is the one which I had on my wall in America, which actually America first. So you see that America is so huge. Greenland is also very big. I think Trump would be surprised to understand how small Greenland is. But probably he looks at this map, that's why he wants to conquer Greenland. But Eurasia is kind of split in 2. And also like this map, which is called Australia first. This is the map where Australia is put into the center and everything else looks very small and insignificant, especially the United States compared to Africa and especially Canada. You see how distorted Canada is over here. So depending upon the projection, again, you draw different picture, you define different perception. This is another thing. This shows the world wealth, how each country differs, is different according to the wealth. So Russia is somewhere over here. This is Russia. And this is China. And this is India. And this is Japan. So this is the relative size of the wealth. This is a very interesting way how the World Bank draws this map. You also see how huge the North America is compared to the South America, actually. So South America is very, very thin. Over here, this is Germany and this is France. So you see that France is actually larger than Russia over here. But what is actually interesting here is that I guess it also is a little bit affected by the Mercator projection. So Russia should be even smaller. This is like the true economic weight of Russia, about 3% of the entire world. Another thing is how we split the data, how we split our data into data classes to show them on the map. The data is absolutely the same. Different is the number of the classes, but each county in Florida. The question is where the Hispanic population in Florida is located. Unfortunately, this post from which I have taken this map has already been deleted or it's disappeared somewhere, but I saved this in my records, in my slides. So this is so-called automatic data classes, automatic equal gaps. You can see that most Hispanic population is located over here. The same data, but now this is split in 5 equal intervals, approximately 11 percentage points in each. And compared to this data, you see that most Hispanic population is located over here, but there is an impression that there is no much Hispanic population over here, right? In this, there is some idea that probably this county and this county have a lot of Hispanic population. Over here, this kind of dissipates. However, you can look at the equal quartiles, 31 county in each, and you can immediately see that most of the Florida has Hispanic population. The same data, the same year, just different way how you slice the data into the data classes, into data categories. And this is something which is also you have to keep in mind when you draw those so-called horopleth maps. Size matters a lot. I like this map. This map is the distribution of Ukrainian language from Wikipedia based on Census 2001. This is from Ukrainian Wikipedia. This is from Russian Wikipedia. At least it used to be some time ago. I don't know how it looks like right now. So what you see over here is that most territory of Ukraine is more or less Ukrainian speaking, except Crimea, except Gagauzia over here. And even over here, there are lots of territories where people speak Ukrainian. If you look over here, you immediately see that Crimea and Donbass are predominantly Russian speaking. Depending upon how you draw the map, what kind of categories you choose, what kind of classes you choose, you can tell completely different story with the same maps and with the same data. And this is important when we draw those maps. I tried my own example. I worked with export-import data from the firms. I got firm level data from 45,000 firms. About 30,000 firms had some kind of territory ID. And the rest 15,000, they were not so much important. They produced some like less than 5% of the total exports. So we just neglected them. We decided the gray areas on the map. And the data were geo-reference. We know exactly rayon ID. I knew exactly the coordinates of each rayon. We had 2 different levels at the same level of the maps, rayons and cities of oblast subordination. They were on the same grid. And we aggregated all the data at the level of rayon, all at the level of city of oblast subordination. And first, I decided to draw some graphs. This was the first graph that I drew. And what I found that most exports come from Kiev. And basically, and for absolute majority of rayons, the exports value is around 0. So these are rayons where the export is coming, but you basically don't see them much. Export imports is basically the same. Then I decided to play with the data a little bit. I got lower 25%, and I found the same distribution. Most rayons did not have any exports or imports. Then I decided to look at the upper 25%. Again, most rayons didn't have any, most rayons in upper 25% also didn't have any exports or imports. And this is so-called linear law. If you work with any data which are measured in money, you will always see this type of distribution. There are always going to be several leaders which produce something like which are responsible for something like 80% of the entire distribution, and the rest 20% produce almost nothing. I tried to import this by rayons using in the interquantile range. This is the same picture. So I decided that probably I should try to show this on the maps. But I also built this so-called box and whiskers plot. Do you know this from statistics a bit? So this was box and whiskers. You can see that we have enormous amount of outliers. So this Kiev, Kharkiv, Dnipro, Donetsk, whatever. And this is the majority of the rayon. So this is also not very much, not very much informative. So I tried to build the equal intervals. Equal intervals, that means all beans have the equal size. And if we have those equal intervals, the map looks like that. Gray rayons have 0 exports imports. You see Kiev over here, which is green, and we see a lot of cities of local oblast subordination over here. So there are some cities which also imported just enormous amount, but we cannot see them much. I decided that this map is probably not the best one, so I decided another one. I decided to use the quantile map. The quantile map means that we have exact number of values in each bean. Not the bean of the x of the same size, but the same number of values in each bean. And if the distribution is skewed, it can be possible to see on the map. It shows a little bit better picture, right? It shows that, okay, we have some leaders. Those very dark green are those leaders. Over here, there are also some leaders. But then I had another question. Why did I decided that there should be only 4 intervals? Maybe there should be 8 intervals. Maybe there should be 10 intervals or 20 intervals. I don't know. I tried this a little bit. And this was 4 intervals. This was 8 intervals. Do you see the difference? A little bit, right? This is 4, this is 8. Then I decided to let's look at the box plot distribution, how it is going to see if we put box plot distribution on the map. Then it just goes like that. And these are 2 different types of maps, and this is where the color matters. This type of distribution is called consequential. That means the color changes consequently from the lighter to the darker. This type of map is called divergenal. Divergenal means that there is some neutral color over here, like this, I don't know, which is light orange. Then the darker it becomes to the blue spectrum, the higher the value is. The darker it becomes in the red area, the lower the value is. So we are trying to show this on the contrast. But again, we have over 700 units on this map, over 670. And this is just too much to grasp. This is the same picture as we had with those dots. It's very difficult to look at them, yes?
As I see, you treat differently here the region and the regional center in export.
It's not actually a regional center. This is city of oblast subordination. What it means, for example, Kiev is the regional center, but also there is, for example, the city of Bravary, and there is a Bravarsky rayon. Bravary and Bravarsky rayon are 2 different units. This was how the data were presented in the stat. This is how they were presented everywhere. This is what I was trying to keep up with their stat actually. Because right now we have a little bit different structure. They have changed it several years ago. Now we have smaller number of rayons, and I think we do not have those oblast subordination cities anymore. Місцеве обласного підпорядкування. Yeah, this was nightmare, especially in Crimea and in Donbass, because in Donbass, in Donetsk alone, most of the cities were the cities of oblast subordination because of some issues with financing, some issues with what they produced, what kind of cities they were connected with in Russia and the former Soviet Union and so forth. So this was the Soviet legacy. And that's just why this map, as I said, it just was not very much representative, but this was kind of okay. So then decided to change the scale. What instead of those 700 data points, we use only 25 oblasts. This also have the equal intervals. It becomes nice and clear, right? But then what happens if we have 4 quantiles? It becomes even better. So this map becomes more nuanced. So it very much depends upon what you would like to tell. Because over here, it basically tells that exports in 2013 majority went from the Eastern Oblast, and almost nothing went from the Western Oblast. So this was one of the one part of the picture. If I wanted to talk about this one, I would say that a lot of exports came from Kiev and from smaller cities of oblast subordination in the east, but the rest of Ukraine did not export much. So everything was located in the cities. And also, if we build the 8 quantiles, we have the picture with more nuance. Over here, all those oblasts have the same color. Over here, we see that Dnipro and Donetsk Oblast were responsible for the majority of, and Kiev as well, were responsible for the majority of exports pretty much throughout the entire Ukrainian history of the modern Ukraine. And actually, if you look at this map, a lot of reasons for the war is explained, because if the front line goes over here, just in 2014, we have lost about 20% of our exports just in 1 day. Another thing which is important to understand is this thing which is called color brewer. Color brewer provides some standardized color maps, and let me try to show you those color maps. I think I can show you this color brewer website. It's over here. And I have to share the screen somewhere again. So this is from here. Yes. So this is color brewer. Yes. So it shows different types how your yes, yeah. It shows different types of coloring the maps and how those maps will be presented. So for example, we get to the sequential mapping. So depending upon how many regions we would like to show on the map, this could be 4, this could be 5, this could be, for example, 8. You see that those regions, they're consequently colored from the darker to the brighter area. And again, it very much depends upon what palette you're going to use. It's just not necessarily going to be the same color. This could be multi-hue, this could be single hue. So for example, it goes from dark green to light green, or this could go from dark green to dark blue to light green. But this is there is some sequential progression from the darker to the lighter color, but also it's possible to see something which is called diverging colors. Divergent colors, you see that they have the same light color in the middle, and then depending upon this color, you can see how different some regions are. So if you would like to underline the difference between different units, you probably would like to use divergent colors, and they're going to show that some of the regions are different and completely different color, and more contrast color. And this is more important to understand, to use those color brewing things. They have actually standard names. And all the packages which draw those maps, ggplot, for example, or spmap in Stata, or something which is very similar to ggplot in Python, they all have those color schemes already embedded. You just have to understand those color schemes, and you have to understand the difference between sequential and divergent colors. So we're going to stop share that one, and we are going to reshare this again. Yeah, I'm here. So this is the exports of Ukrainian goods using this divergent scheme. So now we see that there is a very light area in the middle, and we see that this area does not export much at all, and this area exports the most. This was before 2014. How it looks right now, I don't know yet. I didn't look at this data for many years, but I think since we have lost most of the Donbass probably, and we have relocated lots of industries to Lviv Oblast, I think now the picture is going to look quite different. And this is also if you would use individual values. Again, you can see the color schemes and the individual values. Finally, there is the last thing about causality or correlation. Everybody knows that correlation is not causality, right? But it's kind of interesting question. If you look at the ice cream sales by month, And if we look the shark attacks by month, we see that they're pretty similar, which probably means that the more ice cream you eat, the more probable that you're going to be eaten by a shark, right? More or less. The correlation is 96% between those two graphs. The questions are very similar, whether maybe it's shark attacks that causes eating too much ice cream. But this is obviously a joke, but if you look at the maps. On the maps, if we draw the pictures, we're going to see one of those patterns. The first is negative correlation, where we see regions with the same characteristics, which are kind of scattered around the map. Or we have positive correlation, where we have more or less same color area in the same place on the map. So for example, this is dark color, this is white color, so we see that those areas are co-located. Then the question that we're asking is whether or not we have something which is called spatial contagion. Is it possible that economic event starts in one region and then spreads to another one by somehow? And this causes a lot of problems with the causality, actually. I like this XKCD comics, and this is what they have found once. They have draw a heat map of subscribers to Martha Stewart Living, which was very popular show on the TV some 20 years ago. And also they have draw consumers of some very strange thing, which is furry pornography. Pornography where actors shape up as different animals. And they see that they are pretty, they are very, where am I? Kind of lost myself. Yeah, they have shown that those two things are very much kind of correlated, right? You see that there is the same correlation. But then they have built the picture of consumers of their website, and they have found pretty much the same picture. What kind of story stands behind these three maps?
High density cities.
This is density, yeah, this is basically density of the cities. So density of every website consumers is very much tied up to the density of the cities. But if you try to show only this part of the story, people will start implying things. And it depends upon you whether you want to imply something or would you like to tell the story from the scratch. Yes.
There is one reason, or like good internet connection or good access to internet, yeah?
Basically, the reason here is the population density. So this is if you have high density population, among those populations, there are some people who are interested in some particular porn. There are some people who are interested in, say, Martha Stewart. There are some people who are interested in their website. This is all related to the population density, to the population in general. And population density basically describes everything. But if you show only this part of the picture, again, people will start implying. Recently, again, there was a map of Poland where people voted for different candidates, and you could see very sharp division between East and West Poland. Also, you could see very sharp division between Eastern Germany and Western Germany. So even after 35 years, after 30 years of the unification of Germany, still there is a mental division, which you kind of imply if you look at the maps. What the story behind this is a little bit different story. So this is the metro studies of the political scientists, sociologists, anthropologists, what's going on over there. But if you just look at the map, you superimpose the map of the division of Germany on the map of the AfG voters right now, you can see very clear correlation. What causes what is kind of different question here. And also, if you look at this map, we probably can see that there is some spatial correlation. There is some spatial correlation in this area, and maybe there is some spatial correlation in this area as well. So this is area with high intensity of experts. This is area of low intensity of experts. Probably something is going on. But if you look at this map, this pattern immediately dissipates. Again, depending upon the scale, depending upon what colors you use, depending upon how you would like to show this, the very same data put into different data bins, into different data classes, into different colors, will tell you completely different stories. So some key takeaways that we would like to discuss here. So when we think that we just show people the map, or maybe pretty much any infographics, and they will understand what's going on there, we should not be that naive. People do not think, people perceive. People see something that you show them, but it is not necessarily, they not necessarily understand what you would like to show them. People see something and then make their own conclusions depending on the context. So whenever you make some infographics, whether this is maps, whether this is something else, you must provide some context just on these infographics. Not on the text, not on the some bullet points, not somewhere else, just on this picture. Without this context, people will perceive information completely differently than you would like to show this to them. So this fast, intuitive perception, it defines the rest of the message that you would like to convey. So if you want to tell some stories with the data, you have to accentuate these stories. You have to show this. You have to point to this. You have to lead people to look at this one. So this is shapes. This is color. This is scale. This is dimensions. This is something that which is very much usable. But whenever you use some infographics, you should be very cautious using default settings, because default settings, they will not necessarily provide the story that you would like to tell. You have to learn how to play with different settings of the same infographics. And also we should remember about all the external restrictions, which could be natural borders, external unobserved factors, too much, too little data. All those things matter for what you would like to show. And if those things remain silent, you will not be able to tell the story that you would like to show. So this is just not enough to show the data on the graph, or just to show some graph, to show some connections. You have to provide additional context in which those data should be put. I kind of like this picture because it shows complexity of some system and basically says nothing more. Thank you. Do you have any questions?
I have some questions.
Go ahead.
Did they actually divide by the population density to find out where their users actually come from, more than normal?
No, they simply took the absolute numbers. If you take the absolute numbers for any characteristics of the internet users for any country, you'll see the picture which correlates with the density of population in that country.
Yeah, but if we divide by density,
no, they didn't divide. They simply took the absolute numbers. The maps actually show the number of users, not the share of the users.
You mentioned the example with East and West Germany, and there is something deeper than a tiny correlation. Maybe this is a little bit out of topic, but could you please explain?
Well, the integration of the Eastern Germany was probably not that successful as it was seen from 1989, which means that it looks like Germany could not provide enough number of jobs and also could not cope with the paternalism which was prevalent in the post-socialist mentality of the people who lived in the Eastern Germany. And right-wing populists basically play on this paternalist mentality. Paternalist mentality basically means the government should provide. And if Germany builds on providing with lots of social goods, lots of public goods, ultimately there is a limit. How many of those public goods can be provided? How much social security can be provided? How much healthcare? How much transportation? If the region is not producing much, they cannot expect that somebody is going to pay for their public goods. And they are not going to produce much if their paternalistic view prevents them from establishing more and more enterprises. This is, for example, was one of the issues of mentality of the internally displaced people in Ukraine from the east to the west. In the east, a lot of people worked for large factories where the factory was pretty much responsible for the entire city, providing with the heat, providing with kindergartens, with the hospitals. A lot of infrastructure was built around one huge factory. And once people appeared in Lviv and Kiev and some smaller places, They kind of expected that somebody would care about them in the same way somebody cares about them in the East. And it takes some time to start thinking in a different way that you have to be responsible for your future. So this is what probably goes on in the East-West Germany.
So basically, the West Germany did not put enough resources to reintegrate, and
they put enormous amount of resources, they didn't put enough of mental power.
yeah.
Once we are talking about behavioral stuff and perceptions, they basically did not populate the population enough. They did not educate the population enough. And this was probably one of the biggest reasons. So they thought that if they provide infrastructure investments, if they provide investments in new buildings, the problem will solve itself. It did not. But this is kind of, goes to institutional economics, to development economics. This is kind of beyond what we talk about here, but this is one of my explanations here.
Thank you.
Yes, thank you. I want to mention that this presentation was actually bigger, but then I insist to hide all slides with Fury pornography. And I'm thankful for that. Yeah, very nice talk. And now we have a break for dinner, for lunch. Yeah. And then we have a cancelled lecture because for some reason Vijay cannot attend, some family problems, I know. And but he is willing to support one of the projects, yes. And then so you have less time, you can talk about projects, you can get a group, you can contact your mentors after you finish this project thing. And we have 16:30, we have a meeting of excursion near the King Danilo monument. Okay, so you can go by walk, you can use car, yeah.
We're going to do a presentation on this means lecture.
I will ask.
Okay.